Alright, this video is on the 5 types of chemical reactions. We'll be working off of a page that looks like this. It's like a chart. And then at the end of this video, we'll also do a little bit of practice, and it looks like this. Okay? Alright, so we have learned how to take word equations and turn them into chemical reactions by identifying the reactants and the products, where to put the arrow. We've learned states of matter and when to identify something as a solid, liquid, gas, or aqueous. And so now we're going to learn that basically in chemistry there are 5 main types of reactions. They can be, all reactions can be categorized into one of the 5 main types, and that's what we're going to learn today. So the first reaction we're going to learn is the synthesis reaction. Okay, and the word synthesis or synthesize, so you can add this in the box, means to make or to create. Okay, so in a synthesis reaction, we're going to be making something. And so the description is that 2 or more substances combine to form one new substance. Okay, so the reaction description is that 2 or more substances combine together to form one new substance. So my general form, meaning not real elements or compounds from the table, but just like A and B. So my general form might be that A plus B yield A, B. Okay, see, that's 2 things combining to form one. Or maybe even A plus B plus C forming ABC. That's also a synthesis reaction. And then a specific example might be something like sulfur plus oxygen, which we learned is O2, it's a diatomic, forming sulfur dioxide. Okay, so that's a synthesis reaction, 2 small things combining to form one larger compound. Okay. The second reaction that we're going to learn is decomposition. The root word of decomposition is decompose, which means to break down. So in a decomposition reaction, one substance breaks down into 2 or more, I'll say simpler substances. All right, so my description says one substance breaks down into 2 or more simpler substances. So a general form might be taking something like AB and forming A plus B, right? One thing breaking down into 2, or maybe even the one we just saw, ABC, breaking into A plus B plus C. Now, these are both decomposition reactions, and what you may be noticing is that the synthesis reaction and the decomposition reaction are exactly the opposite of each other. Okay, they're opposites. They're reverse reactions, so to speak. So a decomposition reaction might be, we could just reverse this one, but it might be like magnesium oxide, MgO, breaking down to magnesium and oxygen, which we know is O2, diatomic. Okay, so synthesis and decomp are related because they're the opposite of each other. Okay, so those are the first 2 types of reactions, synthesis and decomposition. The next one is called single replacement. Some books, textbooks, professors call it single displacement. Okay, but it's technically the same thing. So my description is pretty simple, but it's one element replaces another in a compound. Okay, so this is kind of silly, and I use a silly example here, but let's say that we have a couple who goes to homecoming together, A and B, and then there's a student who goes to the dance by himself, we'll say. And so partway through homecoming, the student who doesn't have a date, he gets pretty bored. And so he comes up to the couple who's dancing and says to the guy, hey, get out of here. I need to dance with your date. Okay, and so that's a single replacement reaction where C comes in and kicks out somebody. So in this case, A and C would get together, and you have B, who is now dateless at homecoming. So that's a really silly example, but it seems to work well with students. They understand that. So let's do an example. Let me make one that's kind of easy. Let's do zinc and, who do I want to do? We'll do zinc. Okay, zinc plus CuCl2. Okay, so it's easy to recognize a single replacement because there's always a single person at the dance, so to speak. So in this case, zinc's going to come in and going to try to kick somebody out, but there's a big discussion about who zinc kicks out. So I'll just intro that real fast. But so we've learned that when things bond ionically, it's always a positive with a negative. You never put two positives together, and you never put two negatives together. So in this case, zinc is going to try to kick out the thing who has the same charge that it does. So zinc is a metal, positive. Copper is a metal, positive. So zinc will try to kick out the copper, okay? And which means that I'm going to be left with copper all by itself, and then zinc and chlorine get together. What we have to do is consult their charges. Zinc is +2, chlorine is -1, so my formula is ZnCl2, and that's a single replacement reaction. Again, there's always a single thing on both sides of the equation in a single replacement. In a double replacement, it's basically the same thing, except it's two switches, so to speak, two replacements. So this would be two couples going to the dance, A, B, and C, D. And partway through, they get tired of each other, so they switch partners, right? They switch dates. So in this case, I would have C and B together, and I would have A and D together, right? Notice nobody is dateless here. Everybody has a date, but they aren't with the person that they came with now, okay, because they have switched. So my specific example might be something like, I don't know, let's see, calcium and bromine plus, we'll do silver chloride. Okay, so if these two partners go to the dance together, they get bored halfway through. I always switch the first ones. It's easier just to think about. So this means that calcium is now going to be with chlorine. Remember, their charges have to be opposite. So calcium's +2, chlorine's -1. So that makes my formula CaCl2. And then we're going to get into this much later about predicting product formulas. But then my other pair is silver and bromine. Silver's +1, bromine's -1. The positive one always comes first. So it's AgBr. And that's my double replacement reaction. Notice nobody is single. Nobody is at the dance by themselves in this case. All right, and then my very last reaction, it's kind of a standalone. It's a little bit different. Like synthesis and decomposition kind of go together. Single and double replacement kind of go together. And then you have combustion, which is kind of an oddball. So a combustion reaction involves something burning in the presence of oxygen, and it creates light and heat, of course. Right, we've all seen combustion reactions before. Now, combustion reactions are different, okay? So they're almost very specific. So in a combustion reaction, most of the time you have something that's called a hydrocarbon. So we'll do a little lesson here. So a hydrocarbon contains only carbon and hydrogen, thus its name. And it could be in a variety of ratios, maybe at CH4 or C2H6 or something like that. It can be lots of things. So there are lots of hydrocarbons that exist. So most combustion reactions are a hydrocarbon. Not all, but most are a hydrocarbon that reacts with oxygen gas, O2, and it produces carbon dioxide and water. Okay? All the time. That's the trademark products of a combustion reaction. CO2 and H2O. So a specific example is going to look very similar to this. It might be CH4, that's methane gas, CH4 plus oxygen making CO2 and H2O. Okay, so that's a combustion reaction. It doesn't always have to be a hydrocarbon. Sometimes it's a compound that contains carbon, hydrogen, and oxygen, but a lot of the times it's a hydrocarbon. All right, now for a few practice, and we're going to go to this sheet. We'll do the first, maybe 6 or 7 together, and then I will have you do the rest of them kind of on your own. So, I will tell you right now that we like to abbreviate because these words are long. So if you want to jot this on your paper, here's how I abbreviate these. Okay, so we have 5 reactions, and I find it easiest to abbreviate them so we don't have to spend our time writing the whole word out. So for a synthesis reaction, we just abbreviate it as S, decomposition as D, single replacement as SR, double replacement as DR, and combustion as C. We kind of use that as a standard in my class, so we don't have to write those words. Okay, so I think instead of writing this, I'm just going to try to hold this paper in front of the camera and talk about them, if it'll focus. Okay, so let's do these. So number 1, we have Mg plus O2 yields MgO. So that is a synthesis because I have 2 small things making one larger thing. In number 2, I have, if you look closely, oh goodness, I'm so sorry, kicked the tripod. In number 2, I have NaCl plus Fe2O3 making Na2O plus FeCl3. If you can look close, they switched partners at the dance. That's a double replacement. So is number 3. It's also a double replacement if you look closely. Number 4, I have HCl plus Mg, making MgCl2 plus H2. Notice I have a single thing on each side, Mg and H2. So that's a single replacement reaction, so SR. Number 5, H2 plus O2 makes H2O. It's 2 things making one larger thing. That's a synthesis. And number 6, I have no single things. It's a double replacement. They have switched partners, so that would be a DR. So my recommendation is that you take a couple minutes. Don't worry about the blanks over here. Just run down this side and label them as either SD, SR, DR, or combustion so that you can practice classifying your types of reactions.